Hello everyone, in this video we have this interesting problem. We have a to the third power plus a to the second power is equal to 392, and we have to find the values of x. But before we begin, you know the deal already. Pause the video and try first, and if you are new here, consider subscribed and also don't forget to like this video. Now let's get started. Ideally, what a lot of people would do is to factor a to the second power out. Then we are left with a plus 1 over here, and this is equal to 392. Then they will find the prime factors of this 392, of which I think it consumes a lot of time. So I don't prefer this idea, right? So what I'm going to do from here is I'm going to equate everything to 0 so that we will get a to the third power plus a to the second power minus 392 is equal to 0. Now you can see the highest power of a is 3, so it means ideally we are supposed to have 3 solutions to this problem, right? But we have this equation, so what do we do? Well, let's break this 392 down. This could be written as 343, which is equal to 7 to the third power. Now, if we take this 343 from 392, we are left with 49, which is also the same as 7 to the second power. So straight away, you can see that we have been able to find one solution to this problem, which is 7, right? But what about the other two? Now let's put these values into the equation so that we get a to the third power plus a to the second power minus 343 minus 49 is equal to 0. So we have a to the third power plus a to the second power minus, we already know that 343 is 7 to the third power, so we have 7 to the third power here, then minus 7 to the second power, which is the 49, right? And this is equal to 0. Now let's group those with the third power and then group those with the second power, right? So we have a to the third power minus 7 to the third power, then plus a to the second power minus 7 to the second power, and this is equal to 0. Now let's apply some identities here. X to the third power minus y to the third power is equal to x minus y times x to the second power plus xy plus y to the second power, right? Then x squared minus y squared, difference of two squares, so we can write this as x plus y times x minus y. So let's apply the same idea here. We have a to the third power minus 7 to the third power is equal to a minus 7 times a to the second power plus 7a plus 49. Then a squared minus 7 squared, that is difference of two squares, we have a squared minus 7 squared, which is equal to a plus 7 times a minus 7. So now let's substitute this one into the equation over here so that we get a minus 7 times a squared plus 7a plus 49 plus a plus 7 times a minus 7, and this is equal to 0. Now you can see we have a minus 7 here, then a minus 7 here as well. So let's factor it. We have a minus 7 times a to the second power plus 7a plus 49 plus a plus 7, and this is equal to 0. Now let's go ahead and then simplify this. We have a minus 7 times a squared plus 7a plus a, that is 8a, then plus 49 plus 7, that is 56, and this is equal to 0. At this point, we can say that a minus 7 is equal to 0, or a to the second power plus 8a plus 56 is equal to 0. Now from this equation, adding 7 to the both sides, we have a is equal to 7. Then from this equation, let's see it has real root or not. We have b squared minus 4ac. Now we are using this expression to test whether it has real root or not. B is 8, so we have 8 to the second power minus 4a, where a is 1, then c is 56. 8 to the second power is 64, then minus 4 times 1 is 4 times 56, that is 224. Now 64 minus 224, that is negative 160. So you can see that we have negative over here, which means this quadratic equation has no real root. So the final real solution to this problem is a equals 7. If you're interested in finding the complex solution for this quadratic equation, it's pretty much simple, right? We have a is equal to minus b, where b is 8, then plus or minus square root of b squared. We have b to be 8, so we have a squared minus 4a, where a is 1, then c is 56. All divided by 2a, we have a to be 1, so we have 2 here. Right. Now simplifying this, we have a is equal to negative 8 plus or minus square root of a squared is 64, so we have 64 here minus 4 times 1 times 56, that is 224, all divided by 2. Now let's go ahead and then simplify this further. We have a is equal to negative 8 plus or minus 64 minus 224. We did this earlier. We have square root of negative 160, then all divided by 2. Now we have a is equal to negative 8 plus or minus. Now this is the same as square root of 160i, all divided by 2. Now simplifying this further, we have negative 8 plus or minus square root of 64 is the same as 4 root 10, then I, all divided by 2. So let's break this down. Factoring 2 out, we have 2 into negative 4 plus or minus 2 square root of 10i, all divided by 2. So straight away you can see that these two will cancel this. Now we are left with a is equal to negative 4 plus or minus 2 square root of 10i. So this implies that a is equal to negative 4 plus 2 root 10i, or a is equal to negative 4 minus 2 square root of 10i. And this is pretty much it. So guys, feel free to like this video, comment, and subscribe. Have a nice day and see you again on the next video.